Hello everyone and a very good morning to all of you. Distinguished delegates and participants from SAARC member states, ladies and gentlemen, I'm very thankful to all of you for joining us in this SAARC webinar. My name is Hassan Javed and I'm working as Research Fellow Renewable Energy at SAARC Energy Center. I shall be moderating today's webinar, the aim of which is to introduce the system design and simulation software and to enhance the capacity of the SAARC professionals on using these softwares. First of all, allow me to briefly speak about the important role played by SAARC Energy Center in the South Asian region. The center, being a regional institute and a technical arm for the SAARC organization on energy matters, has contributed tremendously through capacity building and regional cooperation of the member states. The center started its operation in year 2008. During last 10 years, the center has emerged as a vibrant and effective SAARC institute, which has played its role in all regional level energy initiatives. The center has to now carried out 100 plus interventions. The reports of these interventions are available on SAARC Energy Center's website, free of cost to anyone who is interested. Ladies and gentlemen, globally there are many professional softwares for designing solar PV systems that allow the users to accurately analyze different configurations and to evaluate the results and identify the best possible solution. There are many softwares in the market which are extensively used by industry and researchers for designing simulation of solar PV systems. These softwares include extensive meteorological data for different cities and PV system components databases, as well as general solar energy tools. These softwares are geared to meet the needs of architects and engineers, researchers, and are helpful for educational training. Ladies and gentlemen, among the many available software, PV Sol and PV Syst are one of the best and most famous software used around the globe for solar PV systems. The solar design company Valentine Software from Germany, with its trademark software PV Sol, has agreed to support us in this webinar. The expert, however, couldn't join us due to last-minute urgency. Nevertheless, we have the recorded version of his session for our participants. We shall run his recorded presentation today. Afterwards, an expert named Junaid from Renewable Resources Pakistan would join us in answering questions of the participants. Dear participants, you will have the opportunity to ask questions to presenters by typing your questions or clicking to your raised hand option into the attendees pane of the main window of GoToWebinar software. You may also send in your questions at any time during the presentation. We will collect these and address them during the question answer session at the end of this presentation. Thank you very much again for joining us, and now we are over to the presentation.
Hello and welcome to the first webinar of 2019. Show an introduction to the system planning with PV Sol or PV Sol Premium, which means we show today the 2D part of the PV Sol programs. My name is Ixen Fiedker. I'm one of the hosts of today's show, and on my side is my colleague Thomas Medeke. Hello, Thomas.
Yeah, hello to all participants. Yeah, also from my side, hello and welcome. After a short introduction, we will change live into the program to show you how it works. And yeah, I wish you a lot of fun and enjoy.
Yeah, what can you expect for today? As I mentioned, we will show you the 2D planning. So we will plan a whole system. It will be an on-grid system with net metering and an electric vehicle. During the planning, we introduced the climate data selection tool, MeteorSim, where you can, of course, select your climate data, or you can also create your own data records. Then we will show you how to define your load, your consumption. Yeah, and then there are different methods to determine the number of modules which you can place on the roof. Of course, you can just enter the module number you want to have in your PV system, but there are two additional tools. One is called PhotoPlot. For that, you will need the digital picture and the reference measurement, and then you can plan with it. And at the end, you have the modules on your picture. The second one is the roof view. Yeah, here this is an overview of the roof, so you just have to enter dimensions of the roof and put the modules. And well, of course, we show you all the configuration, etc. And then at the end of the planning, we also make an introduction to configure with the polymorphic configuration and how to configure our optimizers. During the webinar, you have also the possibility to ask some questions to us. Please use the chat function for that, which you can find on the right-hand side of your screen. But I would like to apologize in advance that it will be not possible to answer all the questions due to the time limit and, of course, the number of participants. So that's it for the beginning. Now we will change into the program. So everything that you will see in the next probably an hour will be live planned. And so this is the start screen, the welcome screen. If you open the program, and here you can find some news about PV soil, for example. So it's like an RSS feed. Here you can, well, as you can see, there are new tutorials available, and then you can just click on the link, take a look at it, or you find then the example project and your last project, the recent projects, etc. Okay, I think before we start, we can say some words about the basic settings you can do, then we will start the planning.
Yes, that's right. I will start with the menu bar on our left-hand side. Here under File, it is possible to start with a new project as well as to open existing project. Of course, you have a link to the recent projects, to backup copies, as well as to example projects. And there you can save your project, and of course you can exit the software. Next to the right, here we will have the databases. And for the databases, all our components are based in the databases, batteries, battery systems, the tethers, as well as the main products, modules, and inverters. And to make the planning more comfortable, and especially the selection of modules and inverters, it's possible to generate or to manage favorites, to create favorite lists. And here, for example, you have different favorite types available, and you would like to add a PV module to a favorite list, so it's easier and quicker to select your module from the thousands of modules in the database. Now, first you have to select here the type of favorite, PV module. Below, you have to select the company. In our case, it should be LG. And here we are. We have to mark the company, and then all available module types will be listed. And you just have to check the module you would like to add to the favorite list, and then it's adopted. And later on, if we have to select a module on a PV module window, then we can limit down the modules to the favorites we have to create it here. And then it's very easy to find the module you want. This is also possible, as I have mentioned, for inverters or battery storage systems, and you can also select modules from different companies. Yeah, that's it for the databases. Now we come to the options, the general data. Here on the user data, you are able to find your company data. You are able to add the company logo, which will appear on the project summary header, as well as on all other pages and on the cover page. If you have a look here to the tree view and click to extend it, then you are able to define your user folder where the projects will be stored. Therefore, you have to press the small folder here. And if you would like to change a place where you would like to store your project files. It's also possible to change the unit system here from SI unit to S unit or SI unit with American wire gauge cable, size. Then here, just as new as it is a PVSO 2019, you can define with which program you would like to start. If you create a new project, if you check this option, then here you can still select. And each time, if you start with a new project or a new project, this system type will be pre-selected. And this is also important here. If you check here, automatic update check once per day, a program starts, the system will check if a new database is available or a new release or a new program version. I think that's it for the beginning. Of course, you can change here the languages. These are the different languages which are available here in PVSol. And here under help, you will find PVSol Premium Online help, as well as information about your registration. Here it's possible, for example, to deregister your software, and then it would be possible to register the software on other PC, for example. I think now we can start with the real planning first.
So
yes.
Okay. So how you navigate here in the program to plan the system? You can see here this icon bar in the upper side of the program, and the planning steps going on the left and the right. You can click on one of the icons, of course, or you can use the arrow keys here. So we now have switched to the first step of planning. This is for the project data, and here you can enter the more general data of the project, the project number, who's the project designer, and here on the lower left hand side, the customer ID, the name of the customer, address of the customer, etc. On the right hand side, there's the first, more important planning step is the start of operation date, and we have selected the end of this month, end of January 2019 here in this case. You can give a project name, and if you have a project image available, you can load it here. So this one, and here you can see what we will plan here with the photo plan, small single family home, and then we put the modules on it. Of course, you can enter project description, and if the address of the installation is the same like the address of the customer, you can just use here this arrow key icon, and then it's automatically adapted from this. But of course, you can also enter the address here. So then let's go to the next step. So we can click again on the icon, and this is here for selecting the system type. So what kind of system we want to plan, type of design, if you want to plan 2D or 3D, and we have to select our climate data records.
And here different type of systems are available. To select these, there's a drop-down menu available. You have a grid-connected system with full feed-in, then a Sure Plus system, grid-connected with electrical appliances, then in addition with a battery storage system, or with an electric vehicle. This is a combination of both electric vehicle and battery storage system. And here in addition, we have also two standalone systems with and without backup generator. And as Dixon has mentioned at the beginning, we would like to show how to plan a grid-connected system with electrical appliances and electric vehicle. Okay, if I selected these here, the system layout has changed, and this is the system we would like to define. Below, you can switch between the two types of design. Today, we would like to show the 2D planning, and on Thursday, at the same time, 5 p.m., we show how to use the 3D design. And to switch from the 2D to the 3D, you would just have to check this box, and then it will be changed. Climate data is also an important step here. Select the climate data. There are two drop-down menus available. On the left-hand side, this is for all the countries. On the right-hand side, for the locations of every country. And here in PVSO, we have more than 8,000 climate data worldwide, around 450 for Germany. The German data are based on the German weather service DWD, and the data outside of Germany are typically based on Meteonorm from Switzerland. Yeah, and you can use this drop-down menu, or you can restart Meteosyn, and this can be done via clicking the small globe icon. And within of Meteosyn, you have also different options. You can select your climate data from a list. Here on the upper left-hand side, there's a drop-down menu to pre-select the country, and then all available climate data sets will be listed in the table. If you have an internet connection available, then it's also possible to select your climate data from a map, from an interactive map. And here in the map selection, there's also available a search tool via the zip code. And here we would like to search for a location in Netherlands. It means first we have to go to Netherlands here in our country list. There we are. And afterwards, we would like to enter here our zip code for this location, and it's 2611. And afterwards, you have to press the start button. And here we are, the yellow one. This is the location we have searched for. And as you can see, unfortunately, this data is not available as a climate data set, but we have data sets available in the surrounding area. Yeah, now you have to decide if you would like to use the climate data location next to Delft, or another option would be that you create a new data set for your location. And therefore, you have to press the small button here on the lower left-hand side.
Yeah, and if we click on it, then a new window appears, which looks pretty much the same like the one before. Again, you can select the country above, and there's a search field, but now we can also search for the location name or latitude and longitude, and again for the zip code. So we enter the zip code here again, and can click on start, and well, now the search location appears with the red mark, and to use it, we have to click on the red mark, then it's adopted here in this location field. The state here and the zip code again. And well, yeah, there are two different options again to create a new record. So if we check here the option Meteonorm, then we create a new data record by interpolation of the existing locations in the database. Yeah. But if you have some old measurements, then you could check here measurement data, and then you would have to enter the data source in the upper field, of course the measurement period, and in the small table you have to enter your radiation data. Well, there are different units available, and you have to click on it, and so on and so on. And if you also have the outside temperature available, then you can enter in Celsius or Fahrenheit, then you can enter. If you don't have the temperature, then it's automatically interpolated. So, but of course, we don't want to bore you with entering all the different data. So we click here on Meteonorm and use the interpolation method. It's based on Meteonorm. And well, so now we generate a new record. Here we are, and it's from the mean period from 1991 to 2010.
Yeah, via OK, we can adopt these data, and here we are. This is the annual sum of global irradiation as well as the annual average temperature. And last but not least, here in this window, we have, or we can define here the AC mains. This means you can enter here for your circuit diagram the grid voltage between phase and neutral. You can define the number of phases, 3-phase, split phase, or 1-phase. And yeah, if needed, you can also enter here the displacement power factor. Yeah, it's possible. And yeah, also the maximum feed-in power clipping. Yeah, sometimes it's not allowed to fed into the grid 100% of your production. In Germany, if you would like to get subsidies from the government, for example, for a system with battery storage system, then it's only allowed to fed into the grid 50% of the nominal power of your PV system. And yeah, this you can enter here. And yeah, another number here, 600. This is a number we calculate the CO2 savings, 600 grams per kilowatt hour. But of course, this depends from country to country and from the energy mix of the energy supplier. I think that's it for this page. Now we have to change to the consumption page. And here are a lot of options to define your consumptions.
Yeah, so easiest one is if you have a net metering system. So it means you just feed everything into the grid which what you produce, and it will be charged against the energy which you use from the grid. Then you could just enter an annual value, of course. If this is small case, maybe it's 3,000 kilowatt hours, or you could enter here monthly values. Okay. So another option would be to define individual appliances. Well, but this would mean you would have to enter the consumption of every single bulb or the fridge or whatever in your. So it's more or less an option if you plan an off-grid, a small off-grid system. Yeah, maybe or some hut in the mountains or something like that. So we will show this here. Then there's the option define load profile. So this is if you only have the annual consumption. Yeah. And then you in the OpenSea, we clicked on this bulb icon here, and here you would have to enter your annual energy consumption. Okay, it's 4,500 kilowatt hours. Then you can define if your weekend consumption is different to the weekday consumption. For example, if you have an office building and nobody is there and at the weekend, then you can enter maybe 20% for Sunday and Saturday, or maybe it's the other way around. Then you have a higher consumption during the weekend, and you can of course enter 120% or 150, whatever. Then of course we need the consumption profile. So click on it, then we have the load, and there are some predefined profiles available. And, select residential household average Berlin here, and press OK. And how does it work? So we just have entered our annual consumption, and this annual consumption is now distributed to the simulation or times of the simulation step, which is on an hourly basis in January. Yeah, and these are so-called normalized profiles, and our 4,500 is now distributed by using these percentages. For example, in January we have 10%, so our annual consumption is 4,500 kilowatt hours. So we use 10% in January, which means 450 kilowatt hours are now used in January. Then, okay, of course, the January has 31 days, so the 450 kilowatt hours are divided by 31 days, so we get daily consumption. It's about, I think, 40.5 kilowatt hours per day. Yeah, and now this software decides in which season you are. It's winter, or is it spring and autumn, or summer? And of course, January is in winter here in the northern hemisphere, of course. We have again a small table here for the hours. Yeah, it's again a percentage value, and for example here at 10 o'clock, we use 3.6% of our 14.5 kilowatt hours daily consumption, and this is about 0.5 kilowatt hours, which then are used at 10 o'clock. So that's how it works. That's how the annual consumption is distributed over the whole year. You can also change here this values. As you can see, we have selected the 10 o'clock value, and then it's adapted into this small field here above the table, and you can adjust the value here, and then click the next one, and then it's changed. You can also enter here the kilowatt hours, so your consumption. Yeah. And afterwards, you have to click on standardize. Yeah. So, for example, if you have measurement over a day or a week or something like that, you can enter the kilowatt hours here for every hour, and then click on standardize, and it normalized to the 100%. Okay. I think so. We have now selected our consumption profile. We can enter holiday periods, but pressing OK. We now enter close. And well, here we are. This is our profile, which can now be used in the plan. So, of course, the easiest way would be if you have an measured load profile for the whole year. So always the whole year is needed. And we could use this option, import your load profile here. But there, as you can see, there are some predefined or already available, but we import now one. Give it a name. Make a comment or whatever. Then, of course, we have to enter a time interval. So in Germany, we normally have 50 minutes resolution, but from 1, 5, 10, 15 up to 60 minutes is possible. So we select 50 minutes, and then we have to define the number of days. So 65. So if it's a leap year or not. So we have 65 days, and this determines the number of values. So 35,040 values you need to have in your file. But what means you need 35,040 rows in your load profile. And there are different formats. Of course, if you get it from the power companies, you need an Excel CSV format or a file format or a text format. And what you have to do in the file is you have to remove the header and everything. Only the load is needed, and the load should be in column 1. And then you need the 35,040 rows. Just one column with the load data, and then of course the rows, and then save it in XSUV or in text box. Okay, then of course we have to select the units, kilowatt, what kilowatt hours and watt hours are available, and the number file format, which means what is the decimal? It's a point or a comma. In our case, it's a point. Then we have to select the file here. Well, it's now household. Then we press OK. Again, OK. And now it's everything was defined right, and we get the data import successful. And oh yeah. This profile can also be used for other plannings, of course. Yeah. And also, if you have a different consumption, you can overwrite then here the consumption and then just distribute it to the well, like it is in this file. So we press OK, and as you can see, you can also use different load profiles in one project. For example, if you have a consumption for your household, and then you have a heat pump or whatever, you can use different profiles. Yeah? But we just remove it now one. And yeah, I think that's it for the consumption page. You can move on to the next page, which is P modules. And here we have to select, of course, the P module we want to use and define a number of modules and some settings like orientation, inclination, etc.
Yeah, and here you can find the option I have described at the beginning. If you have managed a favorite list of favorite modules, if we uncheck this option and you're using the drop-down menu, then all companies are available. And if you check this option, selection only from my favorites, then of course a dummy module as well as the LG module we have added to our favorite list is available for the selection. Another option would be the detailed selection of modules. Then you will have access to the whole database. And yeah, this is how it looks like. On the left-hand side, these are all available manufacturers, and on the right-hand side, in the big window, these are the corresponding module types. And this one here, this is the module we have selected. This is our favorite. On the upper side, small icon bar. This is to create a new data set, for example, and then you are able to define your own PV module using the datasheet from the manufacturer. Another option would be to copy one of the existing modules, and if you have copied one, then this data set is also free to edit. Yeah. And yeah, I think that's it for the databases. And now the module is selected, and now we come to the three options you have to define your module area here in PVStore in the 2D part. As mentioned it at the beginning, the easiest way is to enter the number of modules or the PV power directly here in these entry fields. Then you only have to define the installation type. These 5 options are available: roof parallel, with ventilation. Then you have roof integrated, without, and with rear ventilation. And of course, you have 2 types of mounted installations: mounted on a roof and mounted on an open space. In case of roof parallel, for example, then you need to enter here the inclination as well as the orientation of your modules or of your roof. And 180 degrees corresponds to the south, 90 corresponds to east, and 270 degrees corresponds to west. And here in the 2D part, it's also possible to take into account a tracking system or tracker systems. And here are 4 types available. It's a single north-south axis. This means the position of the rotating axis. This is in direction from south to north, and the module will be followed from the east to the west. The next option is single east-west. Here, the rotating axis is in direction from east to west, and the module will be orientated to south and to north. Then we will have here a single vertical rotation axis. It only follows the azimuth of the sun. And last but not least, this is a dual axis tracking. Then the module will follow the sun height as well as the azimuth of the sun. Okay, this is the direct input of data. Now we come to the additional options. If you don't know how many modules you can place on a roof, if you would like to determine the number or the maximum number of modules, and here 16 as mentioned, photo plan and the graphic coverage, the roof view, and the planning with the digital picture and the reference measurement. And this is the option you would like to start with. You have to check, and afterwards you have to press the edit button, and then you need to import one picture here or a digital picture, and therefore you have to click on File, Import Picture, and here we are. It's in the family home, and this is the roof we would like to cover. Here we would like to determine the maximum number we can place on a roof. And then the first step, we have to bring these red arrows to the edges of the building, and this is to detect the vertical axis of the building, because it's also possible here in photo plan to calculate the roof pitch from this digital picture. And this can be done if you click these arrows with the left mouse, hold the left mouse key pressed, and then you can bring it here, for example, to the left edge of the building. Change the length of the arrow, and then you have to bring the other arrow to another edge of the building. And now the vertical axes are defined, and what we have to do in the next step is we have to define a geometry. And therefore we have to click the small cube here on the upper left hand side in this icon bar to create a new layer. And therefore you have to click into the edges of the roof. As you can see, here's a small entry field for the distance from the eave to the ridge, as well as for the ridge and for the eave. And yeah, here you have to enter the reference measurement, and this is to scale the picture. And in our case, it's around 10 meters. Please enter 10, and yeah, then you have to press the enter button, and here we are. This is automatically adopted here, the distance from the eave to the ridge, and also the plane, the pitch of our roof is calculated. It's around 40 degrees. Last but not least, we have to define the photovoltaic area here. Therefore, you have to click this small wafer. And again, you can click into the edges of the roof. And afterwards, we can cover the roof with modules, and then we can see how many modules we have placed here on this roof. Okay, here under product choice, there is another option. In blue, this is our solar area, our photovoltaic area. Under product choice, you can change the color of the border of the modules, for example, matte gray. And below, this is to rotate the module by 90 degrees from a vertical installation to a horizontal installation. And here you can define the module spacing between the modules in horizontal and vertical orientation. And normally it's 2 centimeters. This is for the fixing material. Yeah, now we have to confirm it's okay, and here we are. Now our module, our solar area is covered with modules, and here with the small center cross, you can bring it a little bit more in the center of the roof. And here we are, we have 3 rows with 9 modules each. And what you can see here on the upper right hand side, also the small skylight as well as the parabolic antenna is covered with modules. We have to remove these 2 modules, and this can be done by clicking the green circle here in the center of the module. And now it's free. And if we press the after button, then all lines and dots here on top of the roof are disappeared. And here, this is the potential PV system. And as you can see, there are 25 modules could be placed here on this roof. And we have also calculated the roof pitch. And now we would like to adopt this data, and therefore have to press this close and back button. And here we are. What you have to do now is you have to press the adopt button, and then the number of modules as well as the inclination will be adopted. What you have to enter is the orientation. This can 25 modules, 180 degrees. On the next page, we have to look for a suitable inverter. And here we will have, again, different options. The easiest way is to ask the program for a configuration. But what we have to keep first is we have to limit down the huge number of inverters. There are here in the database more than 5,500 inverters. And if you don't limit down the number of inverters, then you will get problems with your RAM. This is the reason, because you have to select the manufacturer first, and then via this small icon here on the upper side here, the left one, this is to select all suitable products, inverter types, and all suitable inverter types are marked with this green hook, and the non-suitable inverters are marked with this red cross. And this is depending on the number of MPP trackers as well as the AC power rating. And this one here is to deselect, and this one is to select the suitable inverters. Okay, and if I press now OK, then we have predefined around 50 inverters, and if you then press this button with the arrow down, then automatically the best configuration of this pre-selection of inverters will be taken here. And here we are. This is Sunny Tree Power 7000 TL20. This is an inverter with 2 MPP trackers, and we have on the first string 12 modules in series, and for the MPP tracker 2, 13 modules in series. And in sum, these are 25, and now everything is fine. As you can see here with these green hooks, there is no error, no problem. It's possible to change the number of modules in series manually. You can also use this drop-down menu, and here you can see the design range. The minimum number of modules in row is 6, and the maximum number is 22. And if we change it here, for example, to 5 modules in a row, then you will get immediately a message and a visualization via this red cross. Something is wrong. You have to check your system. And one reason, of course, is that the total number of modules now is 18, not 25, as we have covered on our roof. And the second problem is, you can see it here on the lower left-hand side in this message field, that the MPP voltage of 150 volts is not reached. We have currently 133. And as you can see, if you click this red cross here, for example, and here we are on the upper bar here on the right-hand side, you will see the minimum and the maximum voltage of the MPP tracking range of your inverter. And this is the one we have not reached. The minimum voltage range of 150. We are outside of the range of the inverter. This means you get less power. Okay, now we change it back to 12, and then everything is fine. And now we come to the second option. If you're under select configuration, you calculate all possible calculations. Press this database icon again. And here, these are the 49 inverters we have pre-selected and the step before. And if we start this calculation, you'll see that we have lots of possible configuration. The total number is 267. Different inverters available. This is the one which is a suggestion from the program. This is best for our configurations, and you can also use Sunny G Power 6000 here. Trend is difference is a sizing factor, and of course we can also use other or combinations of inverters. I think that's it for the configuration, and we should move on to the electric vehicle.
And here, well, it's similar to the selection of inverter or PV module. We have 2 fields. One is for the manufacturer here, and we select here the Mercedes-Benz, and then the corresponding module types the manufacturer has. Then you can enter the number of vehicles you want to have in your simulation. Well, 2, 3, 4, whatever. We have just one. And in the lower part here, we have to define the range per week, so the kilometers which we drive per week with our cars. I think we let it at 350 kilometers. And then you have to define the time. Started from 027 and then from 18 to 23 o'clock. Okay, then we can copy the values for all days, for example, here, and then it's automatically copied to the rest of the day. Then we change it, for example, for the Sundays, or we sleep a little bit longer, and then we breakfast, and then we trip outside, or whatever. It's also possible to define different groups. For example, if you have a different car, then we add here a new group, and here we could select BMW or whatever. So if you have different types of electric vehicles available, then you have to define different groups here, and then you can define the kinds of charging separately, etc. What else is important here? So I think we will go to first. So there is, you can see here the charging mode. 2 different charging modes are available. One is standard. What does it mean? Standard means if you are at the charging station, then the battery of the electric vehicle is loaded up to the limit. This it's full until it's full. Doesn't matter if you have PV power or PV energy available or not. Yeah. If you use PV optimized, then it means, well, the battery is also loaded, but not up to the end. So it's not fully charged. It's only charged up to the point that you have the next, or that you can drive the next ride. Yeah. So if you don't have PV
What? To enter the cable length for the AC cable. This means from the meter to the inverter. And here you need to enter, okay, square as well as the material. You have the choice between copper and aluminium. Yeah, and then we have to scroll down, and yeah, now we have to define the cable for the different strings as well as cross section. Again, for MPP tracker 1, upper cable here, this should be 20 meter, but please pay attention. Here you need to enter the go and return length. For our AC cable, we had to enter the one-way length, and here we have to enter the go and return length. In our case, it's 20 meter, and we have selected 4 millimeter square and as material copper. And then we have to switch to MPP tracker 2, and here again, 20 meter, 4 millimeter square for cross section and copper. And here on the lower right hand side, we can have a look to the losses of the selected inverter and the total losses of all inverters. And this is around 0.3%, around 25 watt. I think that's it for the cable losses. And now we come to the circuit diagram here. Yes.
Yeah, basically depends on the system we have defined. So all the different things we had add fuses and so on and so on. What you can do here, you can add a legend or drawing space here, and legend can be sit on the different edges, top, bottom, left, right. Yeah, so can be changed here. It can also be exported to a PDF or just a digital image, a PNG file, or so vector-based graphic files, SVG, and this can then be opened in a CAD program, for example, if you want to add something more to the diagram, which is not included here. Okay. I think next one, this is for the financial analysis. Here you can define the cost of the system. And of course, you can make some settings for the income.
Yeah, therefore you have to press the edit button here. And then in the window for general parameters, here you have to define the assessment period. In Germany, it's 20 complete years plus a year of installation. Here below, you can take into account the loss of the value of the money, the inflation. Yeah, this can be entered here. Yeah, it's around between 0.5% and 1%. And another information you will get here is what you have entered, all entries in net or in gross, and if you reopen the program after maybe months or years, that you know, oh, I have entered all values here in net or gross. Yeah, if I change to gross, you will not get the tax. The tax will not be added to all of your entries you have made here. This is just for information. Yeah. Okay, then we have to move on to the next page, and therefore you can use the buttons here on the bottom edge, or you can also use here the tree view and click directly in the next window. Yeah, and here you have to enter the cost of your system. This can be done in a specific way, euro per kilowatt peak, or you can enter here the total cost of your system. It's also possible here to define outgoing and operating costs. For example, maybe it's 1% of the investment per year. It's also possible to enter the euro per kilowatt peak in year or the total cost per year. These are the three options you have. You can also take into account inflation, and it would be also possible to enter this more details, these values. Yeah, this is an option here for the total cost of the system to use the detailed entry, and then it would be possible here to add further positions. For example, if you press this button here on the lower right hand side, add position, then you will get a new row here in the table, and then you can separate PV modules, inverter, and sub-constructions, and all these options would be possible. Yeah. Okay. I think I have to enter something. Can we remove it? No. Oh. Seems not to work. Okay. Okay, then we go back here to income and expenditure. Further option, annual consumption costs or outgoing other annual costs if you have to pay for insurance, or if you have to pay a rent for a roof or your object, then this can be entered here separately if you don't have to sum it in the operating costs here and the overall operating costs. Okay, then we move to the financing.
Well, I think we should remove the hook for the
also for the detail.
Yeah, because we now have only 1,502, which is that would be a nice system. Everyone would want to have it.
Okay. Yeah, what is the normal price? I think around 1,000.
I think we had
500 per kilowatt peak.
Makes more sense.
Makes
more sense?
Yeah. Okay.
So I think we can go to the financing.
Yes. Here you are able to define up to 3 loans. We would like to have only 1 loan here. And here you can enter the loan capital or the loan capital as percentage of the investment. And we would like to finance 100% of our system. And here you can define the term, the repayment-free initial period of 2 years. If it's an installment or annuity loan, and the loan interest, I think it's a little bit too high. Maybe it's between 2 and 5 and 4%. And the repayment period you can also define here: monthly, quarterly, half yearly, and yearly. And we select here quarterly, and now we come to the tax. But
we recommend that you ask the tax consultant.
This is
for example, in Germany, it's not allowed that everybody can do that.
maybe
I don't know how it's in your country, and but of course,
the safety solution. But if you would like to take it into account, yeah, then you set a hook here, allow for tax, and you need to enter here the tax rate. Yeah, and it's also possible here to take into account depreciation. You need to enter here the years, and then it's a linear straight line, or it's a reducing balance, degressive depreciation. But as we have mentioned, we would ask a tax consultant and calculate this financial analysis without any taxes. Okay, now we have to look. And yeah, what we have also to decide is allergy balance, feed-in concept. There, if you would like to use the surplus feed-in, or if we would like to use net metering, as mentioned at the beginning, and in some countries, net metering is a common option. For example, in Denmark or the Netherlands, yeah, this means that's a public grid. It's a huge storage system, and you can fed into the grid all what you have produced, and afterwards it will be charged how many kilowatt hours you taken from the grid.
Yeah, and if we select net metering, then we have to define, of course, a tariff. Yeah, so what are the costs for from your limit, which you have normally to pay to the power company if you take some energy from them. Yeah, so because this defines our savings, for example. Yeah, so we just have one here for the Netherlands, and as you can see here, you can select country and you can enter a city and so on, some what's called and energy supplier and so on. And then to residential account, then it's how it's accounting. If it's an annual accounting or if it's a monthly accounting here. Yeah. So yes, it can. And there also in some cases you have to use or take a minimum quantity from the energy supplier, from the grid, of course, yeah. And then you also have to define if there's a consumption for the surplus. So it means if you have, or if you produce more than your consumption is, yeah, so more than you take from the grid, and sometimes you are paid for the additional feed-in, yeah, but in some cases, of course, not in most of the cases, you're not paid for it. The important thing is, of course, on the right-hand side. Yeah, here you have to enter the energy price, which you have to pay. It's also possible to define a different tariff. That you have different tariff periods. For example, a high tariff and a low tariff for different times. Then we would have to enhance the number of different tariffs. In this case, because maybe you can just click on it, that you can see how it changes, and then you have to define here the different in this matrix here the different tariffs when they apply for different hours in the month. You can see that here tariff period 1 and tariff period 2. So click on it and tariff period 2, for example. And this is how it works. Yeah. We have just one here, and click OK, and then select it. Okay. Of course, if you don't use net metering, then you have to select. Maybe you can change back from it. Then we have to use a feed-in tariff. Yeah, so that's and then you can select it by add, for example here. They are different for Germany, of course. We have some available here, yeah. But maybe then we can go here to the Netherlands. Okay, we have one. You know, it's our net metering tariff. Okay, so that's the right one. Anyway, so yeah, then you have to define a net metering tariff for your country, and that's what you paid for the feed-in, yeah. And of course, we have some savings because we have some own use then, yeah. And again, we have to define a consumption tariff. Yeah. Okay, so but yeah, let's switch back to net metering here. Yeah, you can also define an inflation rate for the energy price here. And well, now we have, I think we have finished the planning of our first system. We can simulate it by clicking on the calculator icon here, and then let's take a look at the results.
And here we are. Here, this is the overview page here from the results, and on the upper right hand side here you can see the overall PV generator energy we have produced, and this is a specific annual yield as well as the performance ratio with around 19%. And on our upper left hand side here in this part, financial analysis, this is the revenue or saving. This is around 1,300 euro per year, and this is the accrued cash flow. This is around 18,000 euro after 20 years. Then below, this is a small graph, and what can we see here? This is in yellow, the PV energy we have produced, and in gray, this is our consumption. And this line here, this is cumulative total energy production. And during winter time, the consumption is higher than the production, and this will change here during summertime, and again in autumn and winter, November, December. It's again a higher consumption as a production, and in total, you can see here we are close to zero. Yes, it's minus 5.1 kilowatt hours. This means that we have to pay for 5 kilowatt hours. We are close to zero. If we charge our production contrast to our consumption. And then you can have a more detailed view. If we click here to simulation, for example, again, you will have our PV system, which will be generated, down regulation, the CO2 emission avoided. Then the appliances, we have defined 4,500. Charge of electric vehicle is another part of consumption, so that we have in total 7,867. Covered by PV power is 2,548, and covered by grid, and so on and so on. Okay. We have also information here about our electric vehicle, how much we can drive with solar power, and it's finished.
And there are different small results here on the diagram editor. If you want to have a really detailed look in the results, you can select different data series. For example, and you can select here if you want to see the days, for the weeks, month, and year. This one can also be, you can set, of course, here the starting date. But you can copy this graph, like all graphs. You right-click on it and copy it, and you just copy the graph. But if you want to have all the different numbers in the table, and you can select the copy table to clipboard, then you can just paste it into Excel or whatever. Okay, so then there are different more graphs available. Then we have the PV system energy balance, where you can see all the gains and the losses. The gains, of course, is radiation, and then there are a lot of losses due to the efficiency of the module, efficiency of the inverter, etc., etc. Then we have here the financial analysis. This is what's interesting here. Savings, of course, and can take a look at the cash flow table. You can see it for every year, the savings and so on, and then if you want maybe the cash flow, cash balance diagram, we can see when we go into the plus.
Yes. Okay, 7.8 years. Yes, really good.
So let's take a look at the presentation. So this is the report which you can give to your customers, and Oops. A little bit. Yeah, here we are. So this is the front page with all the entries which we have made at the beginning of the planning, and on a project data. You can see the data from the customer and the contact person and so on, and then of course our picture here. Then yes, project overview on the next pages, and then the yield, and so on, so on, so on. Down, if you go to the last side, I think there's the picture from the photo plan, and there's the energy balance, and so on, so on. You can also decide what should be in the report here. Yeah, there's a link here for the options, and here there's a long list of all the things which are included in the presentation, and you can mark up the hooks, and then they are in, or you can remove the hook, and then of course they are out. Yeah. Then you can save it, of course, as default, and then every time if you start a new project, then this defaults or your defaults are then used for the presentation. Yeah. It's also possible to select the different language for the presentation report, different to the program languages. Yeah. For example, there are some additional ones like Turkish, Chinese, Danish, and so on. Yeah. Okay, so the report can be printed out. You can export it to a Word or a PDF. And yeah, I think that's it for the planning. I promise you that there are different ways of determining the number of modules on the roof. We have shown the photo plan, and now we go back to the PV modules page and add a new model area, so an additional one. So we click on new. You can see then we have module area 2 here. So click on it, and again we have to select our favorite module here. So, and now we use the graphic coverage. So click on it, then again edit, and like for the photo plan, a new window opens, and now we have to enter the dimensions of our roof.
Yeah, since this is the roof view of the default project, and you would like to start with a new one, and therefore you have to press the upper left-hand icon, create a new 2D object, the small triangle, a trapezium, and yeah, here you have to decide about the standard form you would like to use, and yeah, we have to select a rectangular form, standard form, because you would like to define the system we have defined with photo plan. And just therefore we have to enter the different lengths here for A and B, and this is 10 by 5.3 meters. And here in the middle on the left hand side we can also define border distances for each of these borders. And in the first step here we enter for all borders 0.2 meters, and when we uncheck all borders, and when we type in directly here in the table for the ridge, this is the length 3 to 4 here. This should be 0. No border on ridge. Yeah, then that's okay. Now we will be asked if the previous roof should be removed, and yes, it should, and here we are. This is our new roof with the dimensions 10 meter by 5.3 meters with the border edges here defined for the gable ends as well as for the eaves. Here below of our graph, here we need to define the roof orientation. Yes, it should be, in our case, should be 270 degree orientated to west. And you can have also to define here the roof angle, and this we know from our photo plan planning, and this was around 40 degrees. Okay, now our roof is defined, and we have to move on to the restricted areas, and therefore we have to click on restricted areas in the tree view, and then again please press the small trapezium to create new forms, new barred areas, restricted areas. And the one we would like to define first is our small skylight, and here the dimensions are 0.24 by 0.6 meters, and to confirm it's okay, And here we are. This is our skylight. This is placed in point of origin, 0, 0. And this is the lower left edge of the building. And yeah, via these X and Y coordinates, we are able to bring it to the right position. And this should be 7.9 and 3.6 for Y. And here we are. And to add a second restricted area, our parabolic antenna, again, we have to click here. This is not restricted areas. Afterwards, a small trapezium. And here is a fourth standard form available. In addition to rectangle, trapezium, and triangles, this is a circle. And here we have to enter the radius. This is 0.2 meters. Again, confirm is okay. And with the X and Y coordinates, we have to define the right position. And this is 8.5 and 4.4 meters. If this is done, we have to change or to move to PV areas. And then again, press this small trapezium. And here again, the standard forms are available. And in addition, another option, fit the roof areas. This is the easiest way to define the PV area, the coverable area. And here then it's the same as the roof size we have defined. And here, if you press OK, oh, something went wrong. What is it? No, then we can delete it. Okay. And again, trapezium, fit the roof area. Okay. Okay. Now it works. And now we can cover the whole roof, the entire roof's modules. And here, what we have to do here is we have to define the installation type. Again, this 5 options are available. Roof integrated, without, and with rear ventilation. Roof parallel. It's also possible to define mounted systems on a roof and on an open space. And if we change here to roof parallel, then we have again here our orientation we have defined and the module inclination. And to cover the roof, you have to do a right click in this coverable area here. And then we can cover automatically, or we can edit the PV area in advance. This means that you can decide about the installation type. The module should be placed in vertical direction or horizontal. And you're also able to define the distance in between the modules in horizontal and vertical direction. Yeah, it's again the 2 centimeters between the modules. And if you then press OK, then the roof will be covered with the maximum number of modules. And again, it's 25 modules. And by these coordinates, X and Y position of PV modules, you are able to center the module field here on top of the roof. And here, if we enter here, for example, 0.2 and 0.45, then it's centered. Here we are. And that's it for roof number 2.
Last but not least, we wanted to show you the polymorphic configuration. So we go to the next window. It's for the inverter configuration. And what we now have to do, we have to configure the module areas together. So we have to mark both. You can press your control key here on your keyboard and then mark it with your left mouse. And then they are both marked in blue. And now we have to click here, configure module together. So, and then it's kind of merged. And so now we have 2 different module areas with different orientations, of course, and that we want to configure to an inverter with 1 MPP tracker and with power optimizer. So we have to click here on polystring. And so now we have to do everything manually. And so we want to plan with the Solar Edge power optimizer. So we click here on Solar Edge for the inverters. So then we have to select our inverter, and we want to use the, I think, 15K. Yeah, 15K. Yeah, that's right. So then we have to click here, or we have to mark power optimizers. So then we have to select the manufacturer, Solar Edge, and then the module which we want to use from the optimizers. And as you can see, we have for module area 1, we have 25 modules. So if we want to use 300 optimizer, then we would need 25 optimizers. And on each optimizer, there's one parameter module and one module series. So each we have just one module, and we have to select here module area 1. Then we have the second module area, it's again 25 modules. So we have to add a row here. And again, 25 optimizers, same optimizer type, but here we have to select module area 2. So that's how you can configure systems with optimizers, or even without optimizer, just with the polystring configuration if you have maybe a small, whatever, or two different, like we have here east and west roof, and then you want to configure on one MPP track. Okay, I think, well, that's it for today. So I would like to thank you for your attention and the time that you had invested. If you need some more information, then please take a look at our website, www.software.com. If you have some questions or some more questions, or you want to give us some hints, you have some remarks with the webinar, please write us an email to webinar@software.com. And well, yeah, thank you again. And on, I think it's on Thursday, we have part 2 of our webinar. So it's 2 days, yeah, same time, and there we will concentrate on the 3D planning. We don't show all these things around, like selection of climate data and this kind of stuff. We just show the 3D planning. Okay, take care, bye-bye.
Yeah, also from my side, thank you very much. And it would be nice if you would be, yeah, well, follow us on Thursday, if you join us. Yeah, thank you very much and take care. Bye.
So thank you very much to the staff and members of Valentine Software for giving this excellent presentation. So ladies and gentlemen, now we move on to a very short and quick question answer session. We have with us local expert from Islamabad, Mr. Junaid from Renewable Energy Resources. And Junaid, the first question to us received from the participant is that are there any limitations of this PV Sol software when using in Pakistan in specific and SAARC region in general from the perspective of solar radiation data sets and tariff models?
No, you can actually put in your tariff models by hand in these softwares, and the databases are actually consist of the complete globe. So there is no limitation from that perspective in the softwares.
So the next question to us is about the performance ratio. Participant has asked, what about this performance ratio of solar PV systems? What is this thing and how does it measures?
Actually, the performance ratio is how much usable current is being generated given a particular amount of irradiations in a particular set of settings of solar system. So it will amount to that how much irradiance is being beamed on your solar panels, and out of those irradiance, how much electricity is being generated. So that's how you calculate PR generally.
Thank you very much. So Junaid, another question from the participant is that suppose we have a PV simulation for a system, any PV system, PV Sol, the software is used for simulation of a system at a particular locality. How much is it useful for another system of same specification, but maybe 500 meters apart from that system, taking all the conditions are same?
If the given conditions and the settings are same, then the distances of around 500 meters or so, it doesn't matter much. It doesn't affect the results that much. So it should be considerably same, and it should be usable for those two sides. The same results you can use for both sides, given all the circumstances and the shading scenes and all that are same.
Thank you very much. Another participant has asked a question that what does the database of PV SIST contains information for other countries like Afghanistan, Maldives, Bhutan, Nepal. The presentation has given brief about Netherlands and Germany, but from the perspective of SAARC countries, are the data sets available for these countries?
Data sets are available for each and every country in the globe, and if even if you find somewhere that the data sets are not available, just like this showed in Netherlands, there was a town which for which the data set was not available and they had to extrapolate it. You can also extrapolate in PVSys as well. Also, you can have the data sets imported from different sources like Meteonom or Solar GIS. These kind of sources will give you very good merit data sets for definitely a particular price, but you can also import those data sets and use those as well.
Okay, thank you very much. So another question, a very short one, maybe sir. Many people here are very interested in the payback period of these rooftop solar home systems. They are talked a lot about in SAARC countries, and how much do you think is the payback period if a normal household installs this solar PV system at its rooftop, 5 kilowatt, 10 kilowatt? What is the average amount of what's in your opinion the payback period?
Payback period is generally around 4 to 5 years, but it mainly depends upon the amount of load you have in your house as well, and the amount of system you are able to install on your roof. So that these two correlate to each other, and the payback periods depend on them. But generally, it's been seen that it's around 4 to 5 years.
So thank you. Another question is received from us is during load management times, grid becomes unavailable for solar grid feeding. So this phenomena is very frequent in SAARC countries. So does PV Sol has any option to recount this loss of revenue? I think he's talking about from the perspective of load shedding and blackouts.
Um, I think PV Sol and especially PV Syst, you can in PV Syst you can account for this, and I think in PV Sol you can also have this. If you explore the software enough, you will find that there will be some feature somewhere there which will account for grid weak grid islanding is the term they use in the softwares. And for PV Syst, I'm sure there is, and I think in PV Sol you will also find it.
Okay. Thank you very much, Junaid. So I guess, ladies and gentlemen, that concludes our webinar. We have addressed most of the questions which we have received today. So with this, I may like to conclude our webinar. Thank you everyone for attending today's session of the webinar. We had listened to an excellent presentation delivered by the representatives of Valentine Software Company. We are also thankful to Junaid for joining us and replying to the participants. The recording of this webinar will be available on SAARC Energy Center's YouTube channel shortly. We would love to hear from you any suggestions and comments for further improvement, plus any suggested topics of your interest on which you want us to arrange future webinars. We would gladly do that. The other part of this webinar shall be conducted on coming Thursday, 25th April at 10 o'clock Pakistan Standard Time. You may kindly register yourself for that session too. An expert from Homer Software, which is a hybrid optimization of multiple energy resources, Mr. Andy Cruz, Vice President of Business Development, will join us all along from Colorado to introduce his software with the participants. So hopefully we'll see you there on Thursday, 10 o'clock. With me signing out. Thank you again for joining us today and looking forward to see you on Thursday, same time. Have a nice day. Bye-bye.